navigation satellite systems. Okay, you will find that there are four global navigation systems used globally. The number one, first of them is the GPS. Okay, then there is this one is run by Russia, we call GLONASS. Then another is one which run by Europe, Galileo, and then the recently one which is developed or has been used, not fully right until now, is by China called Ito, and we also call it for short for the compass. So these GNSS, as you know that they are used for the position, timing, and navigation. Means they can find out where we are and what time it is and where I am moving or the vehicles are moving. So PNT is the main public service for them. Apart from this, these four GNSS signals, which are in gigahertz, they are also used for quite a lot of research for weather forecasting, meteorology, and so on and so on. Okay, if you guys go to the website, the applications of GNSS for public and research, you will find that nowadays they are most widely used for the public services. You guys know that if you look at planes now, they have got GPS system now. Okay, even if the cars have got the GPS, you can see where are you traveling. Okay, so now this GNSS has become a part of our life. Okay, for the practical use as well as for the research. Okay, here. So this one, if you look at here, this is called as a GNSS. Okay. So this is a part of the global navigation satellite system, but this is the BIDO system of it able to record the signals coming from Chinese system. Okay, here those GPS range here, right? And it is used for ionospheric monitoring. Okay? We established it in October 2019. I think the Neil played a quite active role for this. Okay, so this is used for research to study the entire ionosphere, because the GPS signals from the GPS satellites, they come to the station here, they pass through the entire ionosphere. With the help of this, we measure the electron density or ionization of the ionosphere. We can measure how this ionosphere electron density is varying from morning to evening, and in the night, means day and night, in different seasons, under different conditions of the terrestrial weather events, for example, like tropical cyclones, earthquakes, volcanic eruptions, and under the space weather conditions as well here. So this one is here. It is very specifically made a base for this. Okay. So this is sometimes about 3 meters, 4 meters under this, and it has got a particular layer of flexible material. Then it has got another layer of different material, another layer of different material, and entire thing to make it came from China from a special research. Okay. So the beauty of this one is here, even if a strong truck goes there, it will not create the vibrations. Okay. So therefore, under those difficult conditions, the traffic passing, the heavy truck passing here, you know that heavy truck pass, you can feel the vibrations. Okay. But then this will absorb those vibrations. Okay. Because aim of using this GPS antenna, GNSS antenna, is to measure the position in the accuracies of centimeter and up to millimeters. For that, you need to avoid these vibrations also here. Okay. So this was very sophisticatedly made. Okay. Particularly, there came an engineer from there who was watching everything how it has been put in. Okay. Here. From here, you will see that is the GNSS antenna here, and from there you will see the wire coming from there. Okay. And then this wire goes from here, all right, here, and then to the pipe and goes to the lab. Okay. And Neil has shown you which signals it is recording. Okay. It is capable of recording the GPS of America, your GLONASS of Russia, and then what we call Galileo of European Union, and then BDS of China. Okay, it can record all those things on its online recording. Then that computer is connected to the internet. There is a network of such stations, not only for GPS, for other systems also. There may be thousands of the antenna systems like this, and we are a part of that global network, IGS. Okay, it transmits the data. There is a check of the data, that is of international quality, and it contributes to the IGS in So these small ones you have seen at several places. Okay. All right, guys. Do you have any question to me? No. Okay. So if you guys look at here, uh, you know that that the clouds play a very important role in the global electric circuit we call. Okay, you guys can look at the global electric circuit. Okay, at the base of the clouds, either you have got positive charge or you have got negative charge. So at the base it is positive, then at the top it is negative, like this. Okay, here. So what happens here? Because of this positive charge with respect to or negative charge with respect to the ground, there is an electric field at the ground level. Okay, and we all are in that electric field. The value of electric field is about 100 to 100 volts per meter. Okay, 100 to 150 volts per meter. So we all are in that electric field. Our body is used to of that. Okay, we feel if I connect, if I touch the 240 volt, that means I get ground electric field plus 240 volt. Okay, and then that becomes dangerous. All right, here. So that's how we are. Okay, if you come here, we have got here this is the atmospheric electric field. Measuring the atmospheric electric field continuously, okay, with respect to the ground, okay. Therefore, we made this as a cement base, because if we don't make a cement base, if the ground grass will grow, your 1 meter distance may change, okay, here. So if the grass is here, the grass becomes like this, then it becomes half meter, your readings will change, okay, base here. If you look at here, you will see the electric machine is moving, okay. This is what it is sensing the electric field, okay. If you want to see like this, I show it, and you are free to see, okay. Here, if I see it here, you will see a mill which is rotating continuously, okay. All right, guys. I give you a couple of minutes. If some of you would like to see it, you can see, but don't touch it, okay. Okay. So this is how it is continuously measuring the atmospheric electric field. Okay, here, and then this EMF is going to the cable there. Okay, you guys know that the electric current and voltage propagate very large velocity. Okay, so it is no time here, and then you have seen here the recording of this one in a laptop, and you have also seen that sometimes it goes like this. Okay, so if there is an strong thunderstorm, okay, here it is also recording the electric field produced because of the strong lightnings in a radius of 40 kilometers from here. Okay, if any strong thunder lightning happens, sometimes we are not able to see, it will generate additional electric field, and that additional electric field will superimpose over a normal electric field, and you can see the fluctuation in the electric field. So we are measuring the atmospheric electric field continuously. Okay, I have got similar station in Vanuatu also. Okay, so Vanuatu also we are measuring. Okay, and then this year I am going to establish another one in Tonga. So we will have in 3 stations measuring the atmospheric electric field continuously. Okay, and then the effect of strong thunderstorm also. Okay. Do you have any question to me? You guys will go to the internet and will write atmospheric electric field, and then you will generate your knowledge, okay? How this is produced and how much normally it is, okay? And what is the importance of that. All right? Okay, I leave you guys 2 minutes time if you guys want to see more.